There is a moment in every astronomer's career when the numbers stop making sense. When the data on the screen becomes something else entirely, something that should not exist. And in that moment, the universe reveals itself to be far stranger and far more indifferent than we ever dared imagine. This is the story of such a moment, and of the object that caused it. An object that came from beyond the edge of our solar system, moving faster than it should, accelerating when it should be slowing down, and behaving in ways that violate everything we thought we knew about how comets, asteroids, and lifeless rocks are supposed to move through space. Its designation is Comet 3 I/Atlas, a bureaucratic name for something that may not be a comet at all. The 3I stands for the third interstellar object ever detected by humanity, the third visitor from another star system. And Atlas refers to the telescope array in Hawaii that first caught its faint glimmer in the darkness. But names are just labels we apply to things we do not understand, and the more we studied this object, the less the name seemed to fit, because 3I/Atlas is not behaving like a comet. It is not behaving like an asteroid. It is behaving like something that knows where it is going. Let me take you back to the beginning, to July 2025, to a computer terminal at the Asteroid Terrestrial Impact Last Alert System facility on Mauna Loa. The Atlas array is designed for one purpose: to scan the sky every night and identify objects that might hit Earth, to give us warning, to give us time. It is a planetary defense system, watching the darkness for falling stars that might not be stars at all, but harbingers of extinction. On the night of July 23rd, the system flagged an anomaly. Not unusual in itself, the array flags hundreds of objects every month, most of them harmless, most of them following predictable orbits that will carry them safely past our world. But this one was different. The velocity was wrong, far too high for an object in a normal solar orbit, and the trajectory was hyperbolic. In orbital mechanics, a hyperbolic trajectory means only one thing. The object is not bound by the sun's gravity. It is passing through, a traveler, not a resident. It came from somewhere else. The astronomer who first saw the data, a postdoctoral researcher whose name would later appear on dozens of papers about the object, initially thought it was a data error. She ran the calculations again, checked the calibration, cross-referenced with other observation stations. The numbers did not change. Within 6 hours, the object had been confirmed by 3 other telescopes, and by sunrise in Hawaii, the International Astronomical Union had been notified, and the preliminary impact assessment had been run. This is where the fear truly began, because for approximately 4 hours, before more precise measurements could be obtained, there was a non-zero probability that this object, this visitor from interstellar space, was on a collision course with Earth. The probability was small, less than 1%, but it was not zero. And when you are talking about an object moving at over 40 kilometers per second, even a 1% chance is enough to wake up every space agency director on the planet. Phone calls were made, urgent, quiet. Observatories across the world were retasked, telescopes in Chile, Australia, South Africa, all turning to look at the same point in the sky, all hunting for a tiny speck of reflected sunlight moving against the background of stars. And as the data accumulated, as the orbit was refined with each passing hour, the fear began to subside. The object would miss Earth, not by much, It would pass within 30 million kilometers in December, close enough to study in detail, but far enough to be safe. Relief, palpable relief, spread through the astronomical community. We were not going to die. But the relief was short-lived, because as the astronomers studied the object more closely, as they analyzed its light curve and spectrum, as they measured its size and rotation, they began to realize that while we might be safe from impact, we were facing something far more unsettling than a simple collision. We were facing a mystery. The object was small, perhaps 300 meters in diameter, roughly the size of 3 football fields placed end to end. Its albedo, the measure of how much light it reflects, was unusually high for an interstellar visitor, suggesting a surface that was either very icy or very smooth, or something else entirely. But it was the object's behavior that truly disturbed the researchers, because 3I/Atlas was not moving the way it should. When you plot the orbit of a comet or asteroid, you are essentially solving a very old equation, one that Newton first wrote down in the 17th century. Gravity pulls the object along a predictable path, a curve through space-time that depends only on mass and velocity and distance. There are complications, of course, the gravitational influence of planets, the radiation pressure from the sun, and for comets, there is outgassing, the rocket-like thrust that occurs when ice on the comet's surface heats up and vaporizes, pushing the object slightly off course. This outgassing creates a visible tail, the iconic image of a comet, and it also creates what astronomers call non-gravitational acceleration, a small but measurable change in the object's trajectory that cannot be explained by gravity alone. We have seen this before. We have measured it, catalogued it, understood it. But 3I/Atlas was showing non-gravitational acceleration without any visible outgassing. No tail, no coma, the cloud of gas and dust that surrounds an active comet. Nothing, just a point of light, moving through space, accelerating. By mid-August, the deviation from a purely gravitational orbit was undeniable. The object was speeding up, and the acceleration was not random, it was directional, always pointing away from the sun, as if something was pushing it, or as if it were pushing itself. The first paper to address this anomaly was published in early September in the Astrophysical Journal Letters, and it was cautious, carefully worded. The authors proposed several possible explanations. Perhaps there was outgassing occurring at wavelengths we could not detect. Perhaps the object was venting material from its night side, hidden from our telescopes. Perhaps. But one name kept appearing in the citations, one previous case that seemed eerily similar. Oumuamua. In 2017, humanity detected its first confirmed interstellar visitor, an object that moved through our solar system and left before we could study it properly. Oumuamua, a Hawaiian word meaning scout or messenger, was cigar-shaped, tumbling end over end, and like 3I/Atlas, it showed non-gravitational acceleration without visible outgassing. The resemblance was troubling, because Oumuamua had sparked a debate that still has not been resolved. A debate about whether some interstellar objects might not be natural at all. The most prominent voice in this debate belongs to a Harvard astrophysicist who has spent the last several years arguing that Oumuamua's strange behavior could be explained if it were not a comet or asteroid, but rather a piece of technology, a light sail perhaps, a thin reflective sheet pushed through space by the pressure of starlight, or the remnant of some alien probe tumbling through the void long after its creators had vanished. His colleagues were skeptical, some openly dismissive. The scientific consensus held that Oumuamua was simply an unusual comet, nothing more, and that exotic explanations should only be considered after all natural explanations had been exhausted. But now, with 3 I/Atlas displaying the same anomalous acceleration, the same lack of visible outgassing, the debate was reignited with new urgency. Because while one strange interstellar object might be a fluke, a cosmic coincidence, 2 suggested a pattern, and patterns demand explanation. The light sail hypothesis was elegant in its simplicity. A sufficiently thin sheet of reflective material, just a few atoms thick, would have an enormous surface area relative to its mass. Photons from the sun, striking this surface, would exert a tiny but continuous pressure, enough to accelerate the object without any need for propellant or outgassing. It was physics, clean and simple, the same principle that allows solar sails to work in our own spacecraft designs. But there was a problem. If 3 I/Atlas were a light sail, it would need to be oriented correctly to catch the sunlight, and as it tumbled through space, as all objects do, the acceleration should vary, fluctuating as different surfaces caught the light. But the acceleration was steady, consistent, as if the object were maintaining a fixed orientation, as if it were under control. This observation, published in October, sent ripples through the astronomical community. Some researchers argued it was merely a coincidence, that the object's rotation period happened to align with our observation windows in a way that made the acceleration appear more regular than it actually was. Others pointed out that natural processes could produce stable rotation, that a carefully shaped rock, sculpted by millions of years of collisions and erosion, might naturally orient itself toward the sun. But a third group, small but growing, began to ask a different question. What if it was deliberate? What if we were watching something that was steering itself? The implications of this question were staggering, because if 3 I/Atlas were under intelligent control, even autonomous control, a probe launched millions of years ago and still following its programming, then we were not alone. We had never been alone, and someone or something had sent scouts into our corner of the galaxy, passing through our solar system, observing us perhaps, or simply charting the cosmic wilderness between the stars. The media coverage was inevitable. By November, 3 I/Atlas was front-page news, the subject of breathless speculation and wild theories. UFO enthusiasts claimed vindication. Skeptics urged caution. Scientists found themselves caught in the middle, trying to communicate the genuine strangeness of the observations while pushing back against unfounded claims. The truth, as always, was more nuanced and more interesting than either extreme. Because whether 3 I/Atlas was natural or artificial, it was teaching us something profound about the universe. It was showing us that interstellar space is not empty, that objects do travel between the stars, carrying with them the chemical signatures of alien solar systems, the frozen remnants of worlds we will never see. Every interstellar visitor is a messenger, a bottle cast into the cosmic ocean. And if we are patient enough, if we watch carefully enough, we can read the messages they carry. But 3 I/Atlas was not finished surprising us. In late November, as the object approached its closest point to Earth, a team using the Very Large Telescope in Chile reported something extraordinary. They had detected a periodic variation in the object's brightness, a subtle flickering that repeated every 11.3 hours. This was likely the object's rotation period, the time it took to spin once on its axis. But there was something else, something buried in the data that took weeks of analysis to extract. The brightness variations were not perfectly regular. There were small deviations, tiny changes in the timing and amplitude of the flicker, changes that could not be explained by the object's shape or composition alone. It was as if the object were wobbling, precessing, its rotation axis slowly shifting in response to some internal force. One researcher described it as watching a spinning top that was also trying to change direction. The mathematics of this motion were complex, requiring sophisticated modeling to understand, but the implications were clear. Something inside the object was moving, whether it was shifting ice, cracking under thermal stress, or something else entirely. 3I/Atlas was not a solid, inert rock. It was dynamic, active, changing. And then, on December 3rd, as the object passed through its perihelion, its closest approach to the Sun, something happened that no one had predicted. The object changed course, not dramatically, not with the sudden violence of a rocket firing, but subtly, precisely, with a deliberation that could not be explained by any known natural process. The acceleration, which had been pointing steadily away from the Sun for months, shifted by 3 degrees. 3 degrees might not sound like much, but in the mathematics of orbital mechanics, it was enormous. It meant that the object's future trajectory, its path through interstellar space over the next million years, would be fundamentally different from what we had predicted. It meant that 3I/Atlas was not following a ballistic arc determined by gravity and momentum alone. It was maneuvering. The data was checked and rechecked. Multiple observatories confirmed the measurements. There was no error, no glitch, no misinterpretation. The object had changed direction, and it had done so at a moment when human telescopes were watching most closely, as if it knew we were there, as if it wanted us to see. The scientific papers that followed were careful, hedged with caveats and uncertainties, but beneath the cautious language, there was a sense of awe and unease, because we had just watched something that should not be possible, something that suggested either a revolutionary new understanding of cometary physics or the presence of technology, of intent, of intelligence. And in that moment, as astronomers around the world stared at their screens, at the numbers that refused to make sense, at the trajectory of an object that seemed to be writing its own story across the heavens, the universe became a different place, darker and stranger, and infinitely more mysterious than it had been just a few months before. The object continued its journey, accelerating away from the Sun, heading back toward the interstellar void from which it had emerged. And we were left with our questions, our theories, our instruments pointed at a retreating speck of light, wondering if we had just witnessed a natural phenomenon beyond our current understanding, or if we had just watched something looking back at us. The readings from December 3rd were distributed to research institutions across 6 continents within hours of confirmation, and what followed was not panic exactly, but something close to it, a kind of controlled academic frenzy as teams raced to analyze the data, to model the trajectory, to understand what they had just witnessed. The maneuver if that is what it was, had been extraordinarily efficient, requiring an amount of energy that seemed impossibly small for such a significant course change, as if the object had found a way to bend the rules of physics just slightly, just enough to make its intention clear without revealing its methods. By mid-December, attention turned from the mechanics of the maneuver to the object's composition, to the chemical fingerprints encoded in the light it reflected and emitted. Spectroscopy, the analysis of light split into its component wavelengths, is one of astronomy's most powerful tools, allowing us to determine the chemical makeup of objects millions or billions of kilometers away. Every element and molecule absorbs and emits light at specific wavelengths, creating a unique signature, a barcode that reveals what something is made of, even if we can never touch it, even if it exists in a place we will never reach. The spectroscopic analysis of 3I/Atlas began in earnest in October, but it was not until December, when the object was closest to Earth and brightest in our telescopes, that the data became truly detailed, truly strange. The first surprise was the carbon dioxide. All comets contain carbon dioxide, frozen into the ice that makes up much of their mass, but 3I/Atlas had an unusually high CO2 ratio, higher even than comets from the outer reaches of our own solar system, higher than anything we had seen before. This suggested that the object had formed in an extremely cold environment, far from its parent star, in a region where carbon dioxide could freeze out of the primordial nebula before most other volatiles. It suggested a birthplace in the deep cold, in the Oort cloud equivalent of another star system, a shell of icy debris orbiting in the darkness trillions of kilometers from any source of warmth or light. But the carbon dioxide was just the beginning. The spectrum also showed absorption lines corresponding to complex organic molecules, hydrocarbons and nitriles, the chemical building blocks of life, or at least of life as we know it. These molecules are not uncommon in space. We have found them in comets and asteroids, and even in the vast clouds of gas between the stars. But the concentrations in 3I/Atlas were remarkable, suggesting either an extremely rich parent system or some process of chemical concentration that we do not yet understand. One researcher described the object as a flying chemistry lab, a natural experiment in organic synthesis that had been running for millions of years in the cold and dark, producing molecules of increasing complexity through radiation and cosmic ray bombardment. If we could somehow capture this object, study it in detail, analyze its chemical inventory grain by grain, we might learn how the building blocks of life arise in the universe, how common they are, how inevitable. And then there was the green glow. In early December, several observers reported a faint greenish coloration in the light reflected from 3I/Atlas, visible only in high-resolution spectra, but unmistakable once you knew to look for it. The color came from diatomic carbon, C2, a molecule that forms when carbon-bearing materials are heated or irradiated, breaking apart and recombining in the thin haze above a comet's surface. We see this green glow in many comets as they approach the sun, as the solar radiation tears molecules apart and excites the freed atoms, causing them to emit light at characteristic wavelengths. But 3I/Atlas was showing this glow even as it receded from the sun, even as it cooled, moving back into the darkness from which it came. The emission was weak, barely detectable, But it was there, a faint verdant aura that seemed to persist long after it should have faded, as if some internal heat source were keeping the surface active, as if the object were not quite as cold or as dead as it should be. The implications were debated extensively. Some argued that the glow was simply the last remnant of solar heating, that the object's interior was still warm from its passage through the inner solar system and would take months or years to radiate that heat away. Others proposed more exotic explanations, radioactive decay perhaps, the slow burning of thorium or uranium in the object's core, or even chemical reactions, acids and bases mixing in liquid pockets beneath the frozen surface, generating heat through their interaction. But a few researchers, the ones willing to entertain the more speculative possibilities, pointed out that the glow's persistence was exactly what you might expect if the object contained some kind of power source, some technology designed to remain active even in the cold of interstellar space, drawing energy from nuclear decay or some principle we have not yet discovered. By late December, as 3I/Atlas reached its closest approach to Earth, passing 30 million kilometers from our planet, roughly 78 times the distance to the Moon, the scientific community had arrived at a kind of consensus, or at least a shared acknowledgement of uncertainty. The object was either an extremely unusual natural body, a comet unlike any we had seen before, shaped by the conditions of an alien solar system and displaying behaviors that pushed the boundaries of our current understanding. Or it was something else, something that carried within it the fingerprints of intelligence, of design, of purpose. Both possibilities were extraordinary. Both changed the way we thought about the universe. Because even if 3I/Atlas were entirely natural, it was teaching us that the chemistry of life, the organic molecules that make biology possible, are common in the cosmos, that they arise spontaneously in the cold between the stars, that every solar system produces these building blocks and casts them out into the galaxy, where they drift for eons, waiting to be swept up by the gravity of some passing star, some young planet, some world where they might find warmth and water and time enough to become something more. The object was a time capsule from a dead or distant solar system, carrying within it the chemical memory of its birth, the frozen record of conditions that existed millions of years ago, light years away, in a place we can never visit. And if it were artificial, if some part of it had been shaped by intention rather than accident, then we were looking at something even more profound, evidence that intelligence arises in the universe, that it builds things, that it sends those things out into the dark, perhaps to explore, perhaps to communicate, perhaps simply because that is what intelligence does. It reaches outward, it asks questions, it seeks connection across the vast and empty distances between the stars. Either way, whether natural or artificial, 3I/Atlas was a messenger, and the message it carried was one of deep time and deep space, of processes that unfold over millions of years, of journeys that span the galaxy, of a universe that is far more connected, far more rich with possibility than we had ever imagined. The object reached its closest point to Earth on December 28th, and then it began to recede, accelerating away from the Sun, climbing back up out of the Sun's gravity well, heading toward the outer solar system and beyond. It would cross the orbit of Jupiter in February, Saturn by May, and by the end of 2026, it would pass beyond Neptune, entering the realm of the trans-Neptunian objects, the scattered disk, that region of icy debris that marks the frontier between the Sun's domain and the true emptiness beyond. Telescopes tracked it as long as they could, watching as the point of light grew fainter and fainter as the object dwindled back into the darkness from which it had emerged. By March, it would be invisible to all but the most powerful instruments on Earth, and by mid-year, it would be gone entirely, beyond the reach of our detection, a ghost fading back into the cosmic background. The data would remain, of course, the measurements and spectra and orbital calculations, the thousands of images captured during its brief passage through our solar system, and researchers would study this data for years, decades perhaps, extracting every possible insight, testing every theory, trying to understand what we had seen. But the object itself would be gone, continuing its journey through the galaxy, following a trajectory that would carry it towards some distant star, though it would take millions of years to get there. And by the time it arrived, humanity might be gone. Our civilization collapsed or evolved into something unrecognizable, or perhaps spread across the stars ourselves, and we might meet this object again, encounter it in some distant system, and wonder if we had seen it before, if it had passed through our home system long ago, in a time we barely remember. There is something profoundly lonely about the trajectory of an interstellar object, the path it traces through the galaxy, moving from star to star over timescales that dwarf human comprehension. Timescales measured in millions of years, in galactic rotations, in the slow dance of stars around the center of the Milky Way. These objects are wanderers in the truest sense, unbound by any sun, following paths determined by the gravitational interactions they experienced long ago, nudged by stellar encounters, by the slow tug of the galactic tide, by forces so subtle and so patient that they operate on scales we can barely conceptualize. And as 3I/Atlas receded from our solar system, as it climbed back toward the depths of interstellar space, it was heading toward a region of such profound emptiness, such absolute darkness, that it challenges our ability to describe it. The Oort cloud, that vast spherical shell of icy bodies that surrounds our solar system, extending perhaps halfway to the nearest star, is often described as the edge of the sun's influence, the boundary where our star's gravity finally fades to insignificance. But the Oort cloud is not a place, not really. It is more of a concept, a theoretical region where comets are thought to lurk, frozen and dormant, waiting for some gravitational disturbance to send them falling toward the inner solar system. No spacecraft has ever visited the Oort cloud, and none will in our lifetimes. It is simply too far. The journey would take thousands of years even at the speeds of our fastest probes. But we know it must be there, because we see the comets it sends us, long-period comets that appear once every few centuries or millennia, their orbits carrying them in from the outer darkness around the sun and back out again, objects that spend 99% of their existence in the cold and the silence, so far from the sun that its light is no brighter than the brightest stars, just another point in the sky, indistinguishable from all the others. And beyond the Oort cloud, beyond even that tenuous connection to our sun, lies true interstellar space, the void between the stars, where the density of matter falls to almost nothing, just a few atoms per cubic meter. mostly hydrogen, the remnant of the Big Bang, drifting through a darkness that has never known warmth, that has never known light, except for the distant fire of stars scattered across hundreds of trillions of kilometers. This is where 3I/Atlas was going, back into that emptiness, that silence so profound it makes the vacuum of near-Earth space seem crowded by comparison. In this darkness, time loses meaning, or rather, it takes on a different meaning, stretched out over scales that make human history appear as a brief flicker, a momentary spark in the eternal night. An object drifting through interstellar space will travel for millions of years before it encounters anything, before the gravity of another star begins to pull at it, altering its trajectory, perhaps capturing it into a new orbit, or perhaps simply deflecting it, sending it on towards some other destination, some other star system, some other brief moment of warmth and light before the long, cold returns. There is no sound in space, of course. Sound requires a medium, air or water, or some substance through which pressure waves can propagate. And in the vacuum between the stars, there is nothing, or almost nothing. Not enough to carry vibration, not enough to transmit the shock of a collision or the rumble of a distant explosion. The universe is silent, and that silence is absolute, unbroken, a quiet so complete that it exists beyond quiet, beyond absence, in a realm where the concept of sound has no meaning. And in that silence, objects drift alone, following paths determined by the mathematics of gravity and momentum, equations that care nothing for the objects themselves, that simply describe how mass moves through space-time, how trajectories curve and intersect and diverge across the vast geometry of the cosmos. 3I/Atlas will spend the next several million years in this silence, in this darkness, traveling at 40 kilometers per second relative to the sun, which sounds fast until you realize that at this speed, it would still take 20,000 years to travel just 1 light year, and the nearest star is over 4 light years away, and the star toward which the object is heading, if indeed it is heading anywhere in particular, is much farther than that, so far that the journey cannot be measured in human timescales, cannot be understood except as an abstraction, a number on a page that represents something so vast and so slow that it exists outside of time as we experience it. But the object does not care about time. It has no awareness of duration, no sense of impatience or purpose or loss. It simply is, moving through the dark, because that is what objects do, obeying the laws of physics with perfect fidelity, neither accelerating nor decelerating, except as those laws dictate, a mote of frozen matter carrying within it the chemical memory of some ancient stellar nebula, some long vanished disk of gas and dust that collapsed under its own gravity to form a star and planets and 1,000,000 trillion comets, most of which will never be seen by anyone, never be named or studied or wondered about. Just more debris scattered across the galaxy, more building blocks waiting for some future world to sweep them up and incorporate them into its geology, its atmosphere, perhaps even its biology. And perhaps millions of years from now, 3I/Atlas will encounter another solar system, will fall toward another star. And if that star has planets, and if one of those planets has life, and if that life has evolved intelligence and technology, then perhaps someone will see the object, will track its trajectory, will wonder about its origins and its nature, will ask the same questions we asked, will experience the same sense of awe and mystery and connection across the inconceivable distances of space and time. Or perhaps the object will pass through that system unnoticed, too small and too dark to be detected. Just another piece of cosmic debris in a universe full of debris, and it will continue on, deeper into the galaxy, toward encounters that may never happen, toward destinations that may not exist, following a path that was determined millions of years ago by forces that have long since dissipated, by gravitational interactions with stars that may no longer shine, with planets that may have been destroyed, with a universe that was shaped by events so distant in time and space that they can never be traced, never be understood, only acknowledged as part of the vast and intricate web of causation that connects everything to everything else across the endless dark. And so the object drifts, and the universe drifts, and time flows forward, as it always has, and the stars burn and die and are born again, and galaxies spiral and merge and scatter. And through it all, through the vast ages and the incomprehensible distances, matter moves according to the ancient laws, the equations written into the fabric of space-time itself. And there is a kind of peace in this, a kind of eternal stillness beneath all the motion, a silence that holds everything together even as everything flies apart. We will not see 3I/Atlas again. It has left us, returned to the darkness from which it came, and we are left here on our small world, orbiting our ordinary star, with our questions and our instruments and our endless curiosity, looking out into the night sky and wondering what else is out there, what other visitors might come, what other mysteries might reveal themselves if we are patient enough, if we watch carefully enough, if we remain open to the possibility that the universe is stranger and more wonderful than we can imagine. The object has gone, but the questions remain, and perhaps that is as it should be. Perhaps the universe is meant to be mysterious, meant to challenge us, meant to remind us that for all our knowledge and all our technology, we are still small and still ignorant, and still standing at the beginning of a journey that will take us across the stars if we have the courage and the vision and the endurance to continue. And with that thought, with that image of an object receding into the eternal dark, we too can let go, can release the mystery and the tension and the wonder, can settle into the silence and the stillness, can allow ourselves to drift as the object drifts, alone but not lonely, small but not insignificant, temporary but part of something eternal, connected to everything through the simple fact of existence, through the ancient laws that govern all matter and all motion, through the quiet mathematics of the universe itself. And so we rest, and we dream, and we drift through the darkness of our own inner space, the vast and quiet realm of sleep, where time has no meaning and distance has no measure, where we float untethered from the concerns of the day, free to wander among the stars of our own making, the constellations of memory and imagination, the nebulae of thought that swirl and coalesce and dissolve in the gentle currents of the unconscious mind. Sleep now, rest easy. Let the universe continue its slow dance without you for a while. Let the objects drift and the stars burn and the galaxies spiral, knowing that when you wake, if you wake, it will all still be there, still mysterious, still beautiful, still waiting for you to look up and wonder and ask questions that may never be answered, but that are worth asking anyway, because that is what consciousness does. That is what it means to be aware in a universe that may not care, but that contains within it the possibility of understanding, the potential for connection, the promise that we are not alone, that somewhere out there in the vast dark, something else is looking up at its own sky, asking its own questions, perhaps even thinking about us. Good night.